So today we will be solving another one problem from TIFR 2020. So it's problem number 8. So this is a problem that is based on very uh, basic conceptual uh, understanding. All right. So as you can see that the function, it has been given to you that this only satisfies this inequality. So one thing that we will be using here is this. So as you have seen that the function that we have, it is satisfying this inequality. All right. So one thing you can actually use from here is that for all x belongs to R, so this is a very famous inequality that mod of sine x is less than equals to mod of x. Now, how will you do it? You can actually take the function f of x to be sine x. All right. So then, by using the mean value theorem, so by using mean value theorem, you can get this, that sine x minus sine 0 is less than or equals to some f prime c into mod of x minus 0. So that is practically mod of x. So if you just write down mean value theorem, you will get this. Now, since f prime of c, so since f prime of c is practically always less than or equals to 1, it is bounded above by 1. So you have mod of sine x to be less than equals to mod of x. Now, if you apply this here in this inequality, if you apply this here in this inequality, what do you have? So you get this, that mod of f of x minus f of y is less than or equals to mod of x minus y whole square. Right? Because I have just replaced sine mod of sine x minus y, that is less than equals to mod of x minus y. So I have just replaced that. So you can actually write it here by using this inequality. So if you have this, then what is the limit of this? Let's say limit h tends to 0, mod of f of x plus h minus f of x by mod of h. Now, you have it like this, that this is x plus h minus x whole square, right? So hence, if you will get h whole square, then you get mod of h. All right. So from here, what you can say, so this will be limit. This will be limit h tends to 0. So if limit h tends to 0, if you have this, then we will find that the left hand side tends to 0. Yeah. Okay. Because it's a modulus function, it's positive, and it is bounded above by 0. Hence, the left hand side has its limit exactly 0. All right. So the moment you have this actually implies that mod of f prime of x is equals to 0 for all x belongs to R. So this practically implies two things: that the function f is differentiable and f prime of x is always 0. Because since modulus of f prime of x is 0, you can say that f prime of x is 0 safely. All right. So from here, you can say that f prime of x is always equal to 0. So now the moment you have f prime of x equals to 0, this practically implies f is constant. So thus we get to our solution to this question of the TIFR, that f is constant. So that's the solution. There are multiple other ways you can do it. You can also take another bound and try to prove it in your own way. But this is one way you can actually solve it. Okay. So, all right. So this is it for today. Uh, we will meet with another TIFR problem next time.